Hello friends, very good afternoon. Myself Dr. M.H. Annaya. In today's video, I will just give some important tips on how to clear the engineering drawing paper of the first B program. And this engineering drawing is also called as engineering graphics. And in some universities, it is also named as engineering visualization. So, friends, in the examination, generally all the students, particularly students with less preparation for the examination, will have a lot of tension. They will not know what to do in the examination and to answer which question, etc. And in today's video, I will tell you some important tricks or important chapters which you can go through and clear this paper in just 48 to 50 hours. And that's the trick for today's how to pass engineering drawing or engineering graphics or engineering visualization in 2 days preparation. Friends, there are about 5 to 6 modules, and they are common for all the programs in engineering in almost every university. So, out of which, friends, I have taken up three important modules, namely points and lines. These two are clubbed together, and they generally carry 15 to 20 marks. And the time taken for this, that is, out of these 2 days, when I say 48 hours, so say you can spare around 10 hours preparation. So say day one, you prepare for 3 hours. You go through the number of videos you have of mine or somebody else. And if you have thorough preparation, and if you go through these 20 videos which I have in my channel, and the channel name is Engineering Drawing by Dr. M.H. Annaya, you should be able to clear these 20 marks with 10 hours preparation. And friends, here you should know what all you should study. So, based on the experience and the expertise I have in this subject, I can tell you a very simple clue to solve the points. Because if you know the projection of points, which will generally carry 5 marks, and the lines carry 20 marks. So, here, since you are following the first angle projection, friends, you need to know the projection of points in the first quadrant. And what are the questions you can have here, friends? The point may be here on HP, the point may be on VP, point may be on the line of intersection of HP and VP, which we call it as XY. This vertical plane is a fixed plane, and this plane can be rotated. And friends, one point on HP, point on VP, point on the line of intersection of VP and HP. Finally, you can have a point in space that is in front of VP and above HP. And these four problems are there in one of my videos which deals with the projection of points. I have taken up different examples and made a simple video, a single video, wherein you can go through and have the complete information about a point of a line lying in any one of these positions on HP or on VP or in front of VP above HP or on the line of intersection of HP and VP, that is XY. So one video will help you to get 5 marks out of 20 marks allocated. Then comes, friends, the other important question clubbed with this is the projection of straight line. Friends, in the projection of straight line, there are about 1 dozen plus problems in my YouTube channel. And by just going through these 20, 15 to 20 problems, that will take hardly 20 into 10, 300 minutes, around 3 4 hours if you take, you will be able to complete those important problems. Amongst these 1 dozen problems, the problems what I write now are very, very important and are usually asked in all the university examination papers. Now, which are those problems? Friends, I will write down here. Number one, they will give you TL, true length of the line, and they give you theta and phi. Along with that, they will give you one of the endpoints. Say A is 20 mm above HP and it is 30 mm in front of VP. So they will give you the true length, the angle made by the line with the HP, that is theta, angle made by the line with the VP, that is phi, and one of the endpoints, either A or B, will be given. And you have to start the solution by marking A dash and A, the front view and top view of this. This is one of the very important questions. Then moving on to the second question, they will give you what's called the true length of the line. Then they will give you the length of the front view, length of the top view, true length, front view length, top view length, and again one of these endpoints like A lying on HP or somewhere like this. So this is A dash and A. One of the end projectors, or they will give you the position of one of the endpoints. So friend, this is one of the most important points here. Then comes friends, the question number 3. They will give you point A on HP, point A on HP, comma, point B on VP, A on HP, B on VP. Similarly, the fourth question, B on HP and A on VP. So along with they will give you what is called DEP. Along with this data, they will give you distance between end projectors. DEP means suppose you have got A dash A and B dash B lying on this, say A dash and this is A. You got B dash and B. The distance between these two parallel lines that are called the end projectors is DEP. Distance between end projectors. Friends, these are the 4 important questions. Along with this, there is one more very important question, and if you learn that thoroughly, you will be able to answer about 5 different problems. The question will be like this, friends. Here, they will give you the distance of NDA, distance of NB, both from the HP and VP. They will give you distance of B, that is, say this point is locus of B, this is locus of B in the top view, locus of A in the top view, locus of A in the front view, locus of A, this is locus of B. Similarly, locus of B and locus of B. Friends, in other words, they will give you the position of the end points A and B of the line if it is capital AB, or the position of P and Q if it is a problem which has got true length PQ. So here, friends, what can be done is there are around 5 to 6 problems which can be worked out on this information. For example, if in this question, suppose front view is given to you, front view is given, and you have this information about this also. Friends, if you know the front view, that is A dash B dash, you know this A dash, and taking that front view as the radius, we can draw an arc, obtain the point B dash. You know A dash and A lie on a vertical line. On the same line, this B dash and B should lie on this. So friends, when they give you front view and also the top view should be given to you, top view. So, and you can take the center A and radius equal to AB, the top view, you can obtain. So you can obtain the projections of the line, which includes finding out the true length, the angle made by the line with the HP and VP, etc. Similarly, friends, in the same problem, they can also give you the angle made by the line with the HP. Suppose theta is given to you, some angle, 30 degrees. So once this is given, you will be able to find out the true length of the line, angle you can find out. Like this, friends, varieties of problems can be solved using this particular data, wherein the end project, that is to say, position of A and B, both are given to us. And friends, here, by going through these 15 problems, say, each will take around 10 minutes, 15 into 10, 150 minutes, and you should be able to score 15 marks plus 5 marks from the what you call the points chapter. So, friends, say in the worst case, you are going to get, say, some 15 marks from this. Next, friends, we'll move on to the solids. In any examination on this engineering drawing, no student can take a very high percentage of marks in the engineering drawing subject unless he has got a clear concept about the projection of solids. No student should omit this particular chapter in the examination, and this will have marks varying from 30 to 40. Approximately 35% of the question paper marks are allocated for this subject. So it is a must that every student taking up this examination, EG or ED, should go through this and he or she should work out this problem. And generally, friends, in this chapter on the solids, the most probable questions are on the pyramids and cones. Pyramids, cones, and cylinders. Pyramids are the favorite choice of all the examiners, and also the cones in some time. So, friends, here in this, we should have clear concept about how the object is to be placed in the initial position. So here, if you are correct in placing the object in the initial position, for that, if you write down the front view and top view, you get 1/3 of the total marks allocated. It will be somewhere between 10 to 12 marks. And similarly, friends, if the first step is correct, say there is a problem on a square pyramid, and say the question reads like this: a square pyramid having side of base 30 and height 70 mm rests on HP on one of its triangular faces. So, friends, very obviously, the correct position for this is you have to place this solid on HP such that one of the triangular surfaces is to your right side, so that in the second position it is going to rest on the HP, and you will be able to see the complete base of the solid. So you will be correct only when you take up one of the edges of the solid perpendicular to VP. It is also applicable to all the prisms and cubes wherein on the lateral surface you have got what are called rectangular faces. The same position, that is, same rules hold good. So, friends, initially, for example, for this square pyramid, say I am going to write down the top view of the square pyramid. That's going to be a square of the given side represented by ABCD, and we have this O. The height of the object will be given. You can write down the front view and top view correctly. This is O dash, A dash, B dash, C dash, D dash. So after writing the initial position, if you are intelligent, you should check what does the line on the extreme right hand gives you, because generally the object is tilted to the right side of the observer after the first position. Friends, if it is a question on a square pyramid resting on triangular face, so this is the correct position, because in this position, this line O dash, C dash, D dash represents one of the triangular face. So once you write it correctly, you are one third the mark. One third maybe a mark like 12 mark is assured to you. In the next position, suppose they say it is resting on triangular face on HP. So whatever the figure you have here, friends, you redraw that or reproduce such that this is rotated here, and this line represent the base A dash, B dash. This is C dash, D dash, O dash. And friends, now the object is resting on O dash, C dash, D dash. There are 3 points on this line. Hence, this triangular face is on HP. So corresponding to that, friends, if you look from the top, you will be able to see the complete base, that is A, B and C, D. So this is A, point B, point C and point D. I will mark it as A, B, C, D. And this is O1 in the center. O is the vertex. I will locate the vertex here. Join this vertex to all the corners of the base. And here, friends, I would like to give you a very important tip. Now the complete base is visible, so let me darken it first. Show by visible lines. All these. Now, friends, when I am joining O to A, it is intersecting the line CD. So whenever two lines intersect, if one of them is already known or confirmed to be a full line, the other line should be dotted line. So I am going to join this O to A by dotted line, likewise O to B by a dotted line. If this were dotted line, this would have become a full line. Friends, for this you get one third the mark. And in the third position, they may say the edge on which it is the shorter edge on which is on ground or HP is parallel to VP. Friends, it is resting on CD. That CD is now perpendicular to VP. Suppose that CD is at some angle to VP. So inclination to VP can be seen in the top view, and keeping this object like the same reproduction of this will give you the final front view, final top view, and this will fetch you another one third of the total marks allocated for the question. Friends, like this, you will have three positions for all the problems on solids, whether it is a cylinder or a cone, a prism or a pyramid. The important choice of the examiners will be generally, as I told before, it would be on the pyramids, pentagonal, triangular pyramids or a square pyramid, and it could be on prism also. Okay, so you have to prepare this very well. And say, friends, in the worst case, you are able to solve this, you are going to get two-thirds of the total marks, two-thirds of this 30, it will be, if it is in this range, minimum 25 marks you will get in the exam. That's all the examination marks. I am just writing down here. So friends, next comes, and before that I would like to give some important hint to you. Whenever you are solving a problem on a line, sorry, not on a plane or on a solid, friends, these two figures will always be identical. Figure number 1, figure number 2. I will say this is 1 and this is 2. They are always the same in case of planes, that is the lamina, and the solids. And similarly, friend, if you call this figure in the top view as 3 and this as 4, these two will always be identical. Same figure is written here. This concept is very important, and I wish every one of you to remember this without fail before going to the examination hall. Now, friends, coming to the third question which you are going to attempt in the examination with the preparation you have in 2 days. So friends, this particular module generally carries 20 to 30 marks, say 25 to 30. And here friends, again the questions will appear on the cones and cylinders. Cones and pyramids you should give first preference, then come cylinders and prisms. You should be thorough with the cones and pyramids of all type in this particular. And second preference you can give to the so-called prisms and cubes. Friends, here the marks is 25 to 30 and hardly you can take and complete this problem in around half an hour time. That is, you can allocate 13 hours of the total 48 hours for clearing this question in the examination. Friends, the object will be specified. The object will be generally resting on HP on its base if it is a pyramid and a cone, or one of the faces, the pentagonal face, hexagonal face, triangular face, etc. in case of prisms and cubes. So here friends, generally the object, suppose say you have got a triangular pyramid. You should write down the top view of that and front view for this. Is so simple, you can just complete this with the given dimensions. And naming should be done like this because many students go wrong in naming these corners A, B, C. This is A dash, B dash, this is C dash, O dash, and this is O. This is how a triangular pyramid looks in the front view and top view when it is resting with one of the side AB normal to VP. Friends, again here there will be first of all locating or initial placing of the object is the first step. This generally carries again minimum 1/3 of the total mark. Total marks will be around 25. So this will carry around, you will fetch you around 8 to 10 marks. Because without correct figure you draw here, you don't get any mark. Then marking of the section plane also carries mark. So section plane say is at an angle of 30 degrees to HP and say it is bisecting the axis, and they will ask you to draw the development of the lower part of the pyramid. So you have to show it by visible lines or dark lines, and you can even call it as P. P is the part which is retained for the purpose of drawing the development. Now friends, for all these pyramids basically you need to know the true length of the slant edges, because in all the developments of pyramids, prisms, cones and cylinders, whatever it may be, they are drawn to the actual dimensions of the solid or true length, whether it is a base edge or a slant edge or a longer edge in case of prisms, all of them should have the true length. So in this case, friends, if you observe the front view, this OC is one of the slant edges. That OC in the top view is parallel to VP, and this will give you true length. So if it is in some other position, you should know how to calculate the true length of that. Now friends, I will take this true length, simply mark the true length. Say this is what are the length you get. Here O dash C dash, mark it as O, taking O as center, this point as radius, you mark an arc. And on the arc, you step up whatever may be the size of that side. If it is 30, in a triangular pyramid, you should mark 30, 30, 30, 3 times. If it is a square pyramid, 30, 30, 30, one more you should take. Since I have taken up this triangular pyramid, I should join and take only 3 steps of 30 millimeter each, millimeter. Join that. Join. And remember, for all the pyramids, these joining say from A to B, B to C, C to A, all should be straight lines because it has got straight edges. All these straight edges are there. You have to join by straight edges. So I am going to join like this, friends. And friends, after getting this, now we will have to see and find out where all the object is being cut. For example, if I am starting from OC, which is a true length line, I can simply mark this distance from here to here on OC. So OC is here. I can just take that and mark as one point. Again, the section plane SS is cutting the slant edges OA, OB and also OC. But OA and OB, these two slant edges, they are not the true length. They are not in true length. So that point has to be shifted to the true length line OC, and this measurement, whatever you get here from O to this point, you have to mark on OA and OB. So OA, OB and again OA, because OA appears twice. So friends, join all these by straight line, straight line, straight line, straight line. And friends, if you are marking this as 1, 2, 3, 4, please follow the procedure correctly, and the sequence is also equally important. So what are the sequence I am following? Right from placing the object, you should follow the same steps. So friends, I have marked 1, 2, 3, 4. 1 is on OA. Yes, I will mark 1 here. 2 is on OB. Come on, 2. 1, 2. On OC, you got point 3. So I have marked this. Now here, friends, 1 to A, 2 to B is retained. So I have to retain that here. 1 to A, 1 to A, 1 to A, and sorry, it's not 4, it's point 1 only on OA. So 1, 2, 3 only you should have. So friends, all these base edges are not touched by the section plane, and hence the full base should be shown by visible line. Dark line, dark line, dark line. Portion from 1 to A should be dark. 2 to B should be dark line. 3 to C is retained, and again from 1 to A here. Friends, if you call this portion as P, this figure will give you development of P, the lower part of the pyramid, or this particular part is called a truncated pyramid. Whenever the section plane is at an angle to the solid axis, the portion that is retained is called a truncated pyramid or a truncated cone, as the case may be. And if it is cut parallel to the base, the portion below the section plane is called frustum of that solid. It could be a frustum of a pyramid or the frustum of a cone. Friends, here in this, marks will be allocated for the initial positioning. For the section plane you have got marks. For the development you have got marks. If you take this as 1 unit and this as 1 unit, at least there will be 12 marks on each, and you should be able to get, in the worst case, 10 marks here and 10 marks here. So totally you are getting 20. Say in the worst case 15. Because I'm just thinking, or the worst case where the student can just clear this paper. So I'm not allocating more marks for it. If you are getting more than what I show here, you should be happy and I will also be happy. So this 25 plus 15 is 40 plus 15, 25, 40, 55 marks. Friends, the passing mark is only 40%, and this is 55 you are getting. Say in the worst case, even if you leave some 5 marks, you are going to score 50 out of 100 in the examination, and you can easily clear this. And friends, for this, just to have a small touch or taste of my YouTube videos, Please go through my video completely, and the name of this video or the channel is Engineering Drawing by Dr. M.H. Annaya. And friends, I would also like to inform you that in the same video, which has got around 430 videos as on today, you got videos of around 250 plus on engineering drawing, and the others are on subjects like civil engineering, like finding out center of gravity, moment of inertia, and all these forces, etc., which you have got in first year. And also for the higher class, namely the third, fourth semester, or fifth semester onward, you have got machine design videos also. If any of your friends are in higher class, or any of your relatives are in higher class, like third year BE, you can share this video with them also, and they will be able to see and gather a lot of information from my videos. Friends, please go through the complete video without skipping anything in between. And if you like this video, please share this with all your friends without fail. And in case if you are not subscribed to my channel till today, please do it today. Thank you very much for watching my YouTube video.